Okay, so what we want to do in this session, and in the past when we used to do the summer camps, we used to go from this step, which is the SIMSTR diagram, and we say, okay, now go put in all of these elements. Put in the switch, put in the DC power supply, put in all these gates, wire everything up on your breadboard. And we found that there are some students who could do that. Most students had trouble because there were just so many wires going around. This doesn't look like there's that many wires, but when you put it on the breadboard, keep in mind that each one of these gates, or these like XOR gates, they're going to need power and ground as well. And so there's 4 connections for these that's not shown, 4 connections for this that's not shown, 4 connections or 2 connections for this that are not shown. So there are a bunch of additional wires that are not shown. Each one of these splits is a separate wire. And then there's switches, and these switches, you can't just connect DC to it. You also have to send ground to it so that they can switch between either DC or ground. So there's wires in addition. So we decided that that was too complex to be able to really do on your own without like a lot of guidance. So what we've done is we've abstracted away this part of the circuit, the power supply and the switches, and this part of the circuit, which is the LED outputs, and those are now on the printed circuit boards. So your printed circuit boards has your input and your output. And what we want the students to understand is, okay, I plug in the printed circuit board into my proto board, and now I need to make only the connections between my switches and my logic gates, and the connections between my logic gates and my outputs. And that will allow them to build the full circuit without having to go through and understand everything all at once. So we've even further trimmed down and added more steps in between. So this year for the camp, we had the circuit and we had them do the wiring of just this part. And even that part, there was some struggles with it because understanding like how the chips are oriented, understanding the different inputs for the gates and so forth was a bit challenging. So what we've done is we've come up with, or I should say Maddie has come up with, this worksheet which has the flow chart as to what the circuit represents. So you'll notice that our XOR number 4, this is now labeled as this top XOR gate in this diagram. So Winter has updated this, so this is AND number 4. And this is connected to the A0, B0, and so forth. So she's labeled these gates. I want to switch and show. So what we want to be able to show, okay. So when you build your circuit, you're going to have 3 types of gates. So you have a chip that actually has 4 separate XOR operations in a single chip. So it's a 14-pin chip that will plug into your proto board. Pin number 7, so the orientation is there's this semicircle and the left, so normally this is rotated, but fortunately this is going to match up with exactly how you're going to put this into your proto board. The bottom left, this one, which is normally the top left, this is pin number 1. This is logic gate number 1. So this is my XOR gate number 1 on my chip. So in the chart where it says XOR number 1, sort of in the middle of the chart, that's going to be these 3 pins. XOR gate number 2 is the next 3 pins. And then there's a ground. So the chip, in order to be able to do logic operation, needs a power supply. So you need to apply 5 volts to VCC and 0 volts to ground. So the printed circuit that you soldered together, that you power with an yeah, with the 9 volt, well, not quite. The printed circuit that you, or the printed circuit board element that had surface mount components on it, that's powered with the 9-volt battery. There's something on that circuit called a regulator. The regulator converts from 9 volts, steps it down to 5 volts. The circuits, these chips, they're designed for TTL, transistor logic. Those operate, at least this generation of chip, operates at 5 volts. If you apply more than 6 volts, you'll fry these chips. So we have to, and if you apply less than 3 point something volts, they won't work. So we need a power supply that's between 3 point something volts and 6 volts, and AA batteries, there isn't a convenient solution to that. So our solution is 9-volt battery, 5-volt regulator, so we get a 5-volt supply coming out of our chip. So I don't have any of the, Yeah, it's what you were soldering yesterday. So the part that you have from yesterday, you have a chip that looks like this. And so you had 9 volts and you had ground. And then there's a circuit inside here. I forgot exactly how it's oriented. But there's something that takes your 9 volts in and your ground, and it outputs 5 volts. And then it goes to one of these pins here, and then the ground goes to a pin here. So you have a 5-volt pin and a ground pin, and you soldered these 5 pins that are then going to plug into your protoboard. So you're going to take your chip, soldered, or I've drawn this backwards. This goes this way. So there's these 5 like this, and then 5 like this. So this one is 5 volts, this one is ground. And then this is like I forgot what it is, A1, A0, B1, B0. And this is like S0, S1, S2, S3, something like that is the circuit that you're going to be working with. So your 9 volt that you're putting in, your battery, it's going to this regulator, and then it's going to output 5 volts. And the 5 volts that you get from this printed circuit board chip that you plug into your protoboard, you then are going to connect it. So you're going to have soldered pins on these 5 connections, and which you did yesterday, and you're going to plug that soldered connection, the pins, now into your protoboard. We separated the pins exactly so that they fit across the gap in the protoboard. And then you'll take the 5 volt, so there's these other outputs, the other parts of the 5 volt that you've plugged in. These are all connected in the protoboard. You need to create a jumper wire that's going to go to the positive rail. And for ground, you need a jumper wire that's going to connect to your protoboard that's going to go to the negative rail. And then your chip, which is sitting should have brought the document camera. So the chip that you have here, you're going to have, for example, your XOR, and you need to power this. So in order to power it, you now need a jumper wire to go from the positive to the row that's connected to pin number 14, and you need a jumper wire that's going to go from the ground to pin number 7. So that's how you power your logic gates.
The 9 volts get from the blue chip
to the protoboard. So the 9 volts on the circuit that you soldered yesterday, there's a regulator inside. So it's going to convert it down from 9 to 5. So now that it's 5 volts, you have that as one of your pins on what you've soldered. So you have a pin that has 5 volts and you have a pin that has ground up to the rail. Yeah, so you're going to plug in these pins. This pin is going to connect to a column, and you're going to have a jumper that you connect from the column up to your positive rail to power up the positive rail. So in this worksheet, for example, it says orientation. So your printed circuit board, we want to plug in the printed circuit board in such a way that this 5 volts is going to sit in position 9F. So column number 9, row F. So if you plug it in that way, then there's a unique orientation of your printed circuit board, and then you can fill out the rest of the diagram relative to that. You're going to plug in your XOR into a specific column. So this pin is, which pin did you use? Is it pin 14 for 16F?
So pin 14 should be plugged into 16F.
Okay, so pin 14 is going to be going into column 16, row F. So that way you have your XORs in a specific spot. Similarly with the and the or, these quad chips, you're going to plug these into specific spots. So this is plugging into 27F, and this one's plugging into 37F. So now, in order for us to realize this diagram, so the diagram from the SIMSR, and okay, so before I switch, so let me zoom in on this a little bit more. So each quad gate has 4 gates inside. So I talked about you need to power it, so 5 volts need to go into pin 14, ground needs to go into pin 7. This is your first XOR gate. So in the updated version of the book, there's going to be let's say XOR number 1. So this is your XOR gate number 1. This is XOR gate number 2, XOR gate 3, XOR gate 4. Okay? So it goes counterclockwise according to this notation. So for example, we have XOR gate number 4. The inputs to that are A0 and B0. So XOR gate number 4 is this one. So what we want to do is we want to connect A0. A0 apparently is going to be, so if this is 9F, 8, 7, 6, 5. Okay, A0, so I labeled it correctly. A0 is sitting in 6, and the U means it's on the upper half. So the numbering system is each column has a number. Unfortunately, you can't, and if you're above, these 5 pins are connected, so it doesn't matter which pin you plug in the proto board. Remember, your proto board, you have 5 things that are all connected to each other on one side of the rail, and you have 5 things connected on the other side of the rail, or of the gap rather. So there's a gap in between. The gap is designed to be able to plug in these 14 pin elements so that you have different pins connected to the top and to the bottom. So we're going to call this the upper half and this the lower half on your proto board, so your white proto boards. You have the upper half and the lower half. So the numbering notation that we have, A0 is in column 6. It's on the upper half. So we have 6U. This is where this pin is currently plugged in. So if you plug in your printed circuit board to the proto board such that the 5 volt is at 9F, then A0 will be at pin 6 in column number 6. Does that make sense? Ask questions. You okay? You okay? Okay. So this is going to go into column number 6. Now, this is the circuit diagram that's equivalent to what you did in CIMSTER. So in CIMSTER, you have this picture. So right now we're working on the wiring connection from here to here. We want to orient this simulation, we want to understand the simulation according to this diagram. So we have XOR number 4. It's going to connect A0 and B0, and the output is going to S0. So we want to write in our worksheet what locations is the start and the end of each one of these wires. And the reason that we do this is a lot of times when students start wiring stuff together, they get really confused as to what they've done, what needs to go where, and so forth. So we're going to have it written out first so that the students see how to translate what they've simulated to something that looks more standard, and then they're going to translate this into what's on the proto board. So we're working on this connection. So the left side is A0. A0 is in 6U. So that's the 6U on the left side of A0. The right side is XOR number 4. XOR number 4 we have is this pin, so it's these 3 pins. I wish I could switch back and forth between, I don't have the textbook, maybe I can put left and right of the screen. Where did that window go? Nope. Oh, it's opening it in, I see. Okay, so we're going to put these two together. So XOR number 4 are these 3 pins. This pin for XOR, this is in pin 16F. So this is going to be 15F. So 15F, or sorry, I'm going up. This is, okay, so this on the proto board is 16F. This would be 17, 18, 19. This is the gap where we're plugging in our integrated circuits. Above the gap is upper. So this position, these 5 columns, or these 5 elements in this column, This is in column number 16. This is in column number 17, column number 18, column number 19. So the XOR 4, it says 17, 18, 19U, meaning that it's using column number 17, column 18, and column 19. So the inputs are 17 and 18. The output is column 19. Okay, so in order for us to make this one-wire connection, we're going to write on the left side, it plugs into A0, which is 6 in the upper. On the right side, it's 17 in the upper. So we've connected to this pin. So the part where it says 6U, and it's going to 17U, this side of the pin, this was our A0. This side of the pin is the input to XOR gate number 4. That happens to be pin number 13 on the XOR gate. Okay. So that's one wire. So we've connected A0 to XOR number 4. Okay, so now I'm going to ask the class, if we're going to go from B0 to XOR number 4, the left side of B0 is where? So we have 6U, and then we're going to have 7U, 8U. So the left side is going to be 8U. So we have B0 now. The left side is 8U. The right side is going to be going to XOR number 4, which is this particular pin. This was 16, 17, 18, right? So it's going to connect to 18U. Okay, does that make sense? Okay, so now your activity, and probably because of time, we're at 4:55. I wanted to bring this group back with the other group before they left for the day. Can one of the assistants check that they're still there and let them know that I'm going to bring them back for a few minutes of final debrief for today? The activity, I guess, that everyone gets to do tonight, and you get to talk with your lab or your partners, is to fill out these other boxes. So we've done the top 2 boxes for you. So for example, we've done the connection between A0 and B0 to XOR number 4. We've done the connection between A1 and B1 to XOR number 1. So we've done these 2. We've labeled which pins these are going to. We want you to do the connection for AND number 4. We want you to do the connection for XOR number 2, XOR number or number 1, and number 2, and so forth.
Can you blow that one up so, because we didn't...
Yeah, you didn't necessarily record the circuit. So take a picture of this circuit, save it so that you know the wiring of what you're trying to achieve. This diagram is identical to this diagram.